Hello friends, welcome back to my YouTube channel MS Maths. In this video, I will discuss GATE Civil Engineering previous year question of ordinary differential equation engineering mathematics. My name is Manoj Solanki and you can watch my YouTube channel for the previous year GATE questions for engineering mathematics and also for the concept. For the concept of ordinary differential equation and short tricks and methods, you can visit my YouTube channel for one short video of ordinary differential equation in which I have explained all the concept related to the ordinary differential equation. In this video, we'll discuss 20 plus years previous year question. So let's start the video with the first question. The order of the following differential equation, ordinary differential equation. So it is a recent one, 2025 one mark question. Order means something that highest order derivative present in that particular differential equation. So if I have this kind of differential equation, then the order of each term we can find. So it is what the derivative of order 3, it is derivative of order 2, and it is derivative of order first. And the highest order present in this particular differential equation is nothing but 3. So it is nothing but third order differential equation. Okay, next. So pick the correct solution of the following differential equation. So it is what dy by dx is equals to e to the power of x minus y. See, whenever you will have this kind of differential equation in which you have e to the power of x minus y, you should separate this. So it means this is dy by dx is equals to e to the power x into e to the power of minus y. I can just write it as like this. Now, one thing, if you have this kind of differential equation in which dy by dx is nothing but f of x into f of y, or so not f of y, something g of y, okay, in which you are separating. What are you doing? You can separate just this function and this function because this is what the derivative, and our aim is to get the solution. It means our aim is to get the integration. So if I will separate it like this, g of y and d of x, or basically like we can say it is nothing but d of, yes, this is the f of x, d of x. Now we can easily integrate with the variable, same variable on the one side. So in the same case, I can do just here, it is nothing but d of y upon e to the power of minus y, and it is what e to the power of x, d of x. And what can I do? I can write e to the power of y, d of y is e to the power of x, d of x. Now I can just integrate. If I will integrate, then this is nothing but e to the power of y, and it is e to the power of x plus the constant. If my all the terms are in exponential, then I will just write my constant as this. Now, if it is e to the power of c, then what can I do here? I can just like take, or even like yeah. In this case, I will just write it e to the power of x minus e to the power of minus x and e to the power of c. If I will take log both sides, then what can I do here? Or nothing, just simple. If I will take log, then I can't match the solution. If I will take just log in this equation, okay, see, wait, in this equation, if I will take log in the on the both side, then it is nothing but my y is equals to then log of e to the power of x plus some constant. It is nothing but, okay, it is nothing but the constant. So my first answer is correct for this question. Okay, so this is just the simple case. Next one, okay, it is one of the important question which is asked in the 2024 2 mark question. A 2 meter cross 2 meter tank of 3 meter height has inflow, outflow, and a string mechanism. Okay. Initially, the tank was half filled with fresh water at time t is equals to 0. It is nothing but the initial condition of differential equation. And inflow of salt solution of concentration 5 gram per meter cube at the rate of 2 liter per second, and outflow of the well stayed mixture at the rate of 1 liter per second are initiated. Okay, and this process can be modeled using this kind of first order linear differential equation. Okay, where m is the mass in grams and the salt at time t in second. Okay, and the mass of salt in grams in tank is 75% capacity. So at the 75% capacity, what is the mass of the solution that we are going to calculate? So at the end, we are calculating the solution of this differential equation. But for this, to solve this problem, we first need the determine to determine the time at which the tank reaches 75% of its capacity. It means the tank dimension. What is the tank's dimension? It means if I will calculate the volume of tank. So what is the volume of tank? So the total total volume of this tank is nothing but 2 into 2 into 3, and it is nothing but 12 meter cube. This is the volume of this tank. Therefore it has 75% of the capacity. So 75% of the tank's capacity, then what is that? Then the volume at 75%, I can just write as 0.75 or 0.75 into 10 into 12. That is nothing but my 9 meter cube, and it is nothing but 900 liters. Now here, initially the tank is half filled with fresh water, which is, so here it is what the initial case. So tank is half filled. So if I will find VI, it means initial case, that is half filled, then 1 by 2 of 12, that is nothing but 6 meter cube, and that is 6000 liter. Okay. Now here, inflow rate is 2 liter per second and outflow rate is 1 liter per second. So what is the net flow or the net rate of the increase in volume? That is basically 2 liter minus, or we have 2 liter per second, and 1 liter per second is nothing but 1 liter per second. That is the rate of that particular net inflow rate. This is nothing but net inflow rate. It means it is what, it is inflow and minus we are going to doing it outflow. Okay, and this is nothing but my net inflow rate. So this is nothing but my net inflow rate. Now what can I do here? The additional volume required to reach 9,000 liter from 6,000. So it means it is what, the 9,000 liter, and it is 6,000 liter. So it the additional volume required. So what is the additional volume required here? If I will subtract from this, then 9,000, then it has 3,000 difference. So 3,000 liter required for that additional volume. Now given that the net flow rate here, what is the net flow rate? It is 1. It means that the time required to reach 9,000 liter is, what is the time at 75% filled? So at 75% filled, it is nothing but 3,000 divided by 1. Okay, it is what, 3,000 liter, and it is what the rate is, inflow rate is 1 liter per second. It means it is increasing in that tank. Okay, what is that? It is, if it is your tank and the outflow rate is 1 liter per second and inflow rate is 2 liter per second, but what is the difference? That is 1. So it is increasing with 1 liter per second. Okay, so now here we can just find it is nothing but 3,000 second. It will take 3,000 second here. Okay, 3,000 second. Now what is the model? What is the differential equation given? That is basically m of dash, it means dm by dt, plus m upon 6,000, m upon, oh, I can't write here. Okay, this is the model basically, in which this is the model in which we have basically to solve this linear differential. What is the solution for this linear differential equation? I will just find the integrating factor. So what is the integrating factor of this differential equation? That is nothing but 1 upon 6,000 plus t of dt. And now I'm going to calculate this. So the solution is nothing but, for this is nothing but, m is equals to my exponential of integration of 1 upon 6,000 t of dt. Okay, plus. So what is this? What is the solution for this? First of all, I'm going to calculate the the integrating factor only. So I can take log both, like I can solve it as using log. So it is nothing but integrating factor is equals to e to the power of log of 6,000 plus t. It means it is nothing but t plus 6,000. Now what is the solution for this differential equation? Then the solution is nothing but the integrating factor into m is equals to, it is the solution of linear differential equation. Okay, integration of right hand side, that is 0.01 into integrating factor, that is t plus 6000, or nothing but I can write it as here just integrating factor. First of all, I'm writing the formula only, that is the integrating factor dt and plus some constant c. Now, what is the solution in this case? M. Okay, what is the integrating factor? 6000 plus t is equals to 0.01 into 6000 plus t dt plus c. So, while solving this differential equation, we'll get the solution. What is the solution of this differential equation? It will be m is equals to, okay, if I will integrate, or this is just a like calculation, then it is nothing but the solution will be 0.016000 of t, of course, after integrating, and it will be t square by 2, okay, and plus some constant c I can write here, and I will just take this on the right hand side, that will be 1 upon 6000 plus t. Now I have the initial data. At t is equals to 0, initially the tank has filled fresh water only. It means no salt were there. So in that case, at time t, my m is equals to 0. It means no salt water were there. It means it was filled with the fresh water only. Okay. Now here I will just put to find this c, that is 0 is equals to 0.01, and what is the case in this case? T is equals to also 0, then this will be 0, this will be 0, then my c upon 6000 plus 0. Okay, so here my c will be if I will calculate from here, of course my c will be 0 in this case. If my c is equals to 0, what can I do? If I will put here, then just my c is equals to 0, then this, what is the solution of this differential equation? Is nothing but simple. I will just remove c from here. Okay, yeah, so this is the solution of my differential equation, or the the value of m. Now it is saying that what is the value after that, the process can be modeled in this case, and the salt is 5 gram per meter cube. So it is saying that solution, the mass of salt at 75% filled. So it means after 300, like 3000 seconds, because of that it is what, at the 75%, what is the time? That is 3000. So I will find just m at 3000. It means I will just put t is equals to 3000, then I can find it, then that is 0.016000 or into 3000 plus 3000 square by 2, the divide by 6000 plus 3000, then the value of m is nothing but, after calculating, it will be 25 grams. So it means the correct answer for this question is 25. Okay, so this is what the case, whatever we have done. First of all, we have calculated what is the total volume, and for 70% of the capacity, we are taking the 70% of the whole capacity, that is what the 75%, and we have calculated the difference of the inflow, basically the outflow, inflow minus outflow, that is net inflow, and after that we have calculated what is the time at 75% capacity, that is 3000. We have just put in this. This is nothing but the simple linear differential equation. Okay, now go to the next one. Okay, so the next question is, wait, yeah, the next question is the solution of a differential equation. What is the solution in this case? The differential equation is kind of like this. It is a third order differential equation, is expressed as this. Okay, these are the solution, and in which the solution is basically like this. Okay, see, whenever you will have this kind of thing, and you are going to calculate alpha and beta, what are the roots of this differential equation? Basically, in that case, how can you find? So first of all, like, what is the differential equation here? That is nothing but y triple dash minus 5.5 y double dash plus 9.5 y dash minus 5 y is equals to 0. This is a constant coefficient of the differential equation of order 3. Then find the auxiliary equation. It means replace y with m. Okay, and y dash with m. Okay, y with 1, y dash with m, y double dash with m square and y triple dash with m cube. See, so it will be it will be e cube, sorry, m cube minus 5.5 m square plus 9.5 m minus 5 is equals to 0. Now it is a third order, quadratic equation here. So if it is a quadratic equation, then one root is given. See, whenever you will have this kind of differential equation, then the solution form, the form of solution. So the form of solution is nothing but, if I have real and distinct root like alpha, beta, gamma, then it will be c1 e to the power of alpha x plus c2 e to the power of beta x and c3 e to the power of gamma x. In this case, what? It is a third order differential equation. It means three constants will be there and three roots will be there and three arbitrary constant will be there. So it is nothing but the complementary function of this differential equation. Because of that, it is a homogeneous kind of differential equation only. So one root is given in this case. See, this is what the solution is given in this e to c1 e to the power of 2.5x plus c2 e to the power of alpha x and c3 e to the power of beta x. So one root is given here. It means it will satisfy this differential equation. If it will satisfy this differential equation, then two both should also satisfy the differential equation. Now, one thing is that you are just one method is that you are just putting here, if one solution is 2.5, it means I will just write as, it is a trick basically, I will just write as, what is my m is 2.5, it means m minus 2.5 will be one of the factor. Just write m minus 2.5 three times, okay, in this way. So it is what, m minus 2.5, this three times. Now your aim is to find this, your aim is to calculate the, this form, this quadratic equation. Now what is this m cube? Just I will multiply with this m square, and this is what, m cube minus 2.5 m square. Your aim is to get, 5.5, but it is what, 2.5. What is required for that? I will just multiply with this, minus of this, because it is minus of 2.5. Then I will just multiply with the second term, that is minus of 3 here. Then it is what, minus 3m. Okay, then it is what, oh, yeah, it is minus of 3m. Then 3m square will be there, but it is what, plus of, if you are going to multiply this, it means it will be 7.5m. Now it is 7.5, but you need what, 9.5. Just you are going to adding in this, that is what, plus of 2. Then it is plus 2m minus of 5 is equals to 0. It means that you have this, quadratic equation here. So 1 minus 2.5 can take common, and it is nothing but m square minus 3m plus 2 is equals to 0. Now it is what, the quadratic equation. You can easily solve this, and it is the factor of this is nothing but 2.5, and the factor for this is nothing but, you know m minus 1 and m minus 2 is equals to 0. So it means the roots are 2.5, m is equals to 1, and m is equals to 2. So using this you can calculate the solution. So this is the solution. This is the first method. Another method is that you can just take these values, okay, and put in this. If it is satisfying this, then that is the root of that particular differential equation. If it is not satisfying, of course it is not. So that is the hit and trial method, but it is just a, whenever you have one root, then you can find another root. Okay, now next question. Next question is related to the 2024 one mark question, in which the, consider the ordinary differential equations. So we have this differential equation. It is saying that which one is homogeneous and exact differential equation. See, what is the homogeneous and what is the exact differential equation exactly. So first of all, what is homogeneous kind of differential equation? Homogeneous means that whenever you will have this kind of dy by dx kind of differential equation, we can write it as f upon y. If I will put y is equals to some mx in that particular differential equation, it should not, it should not in the form of different form. It should not convert it in the different form. It remain in the same form. It means while taking dy by dx, okay, it is saying that one thing is that P is homogeneous, P is homogeneous, and it is not exact. Okay, it is talking about P for homogeneous, and for Q it is talking about the exact differential equation. So we'll just check P for homogeneous case. So it is x power 4 plus 3x square y square plus 2y power 4 upon x cube y. Okay, in this case, see, one thing is here. If I have this kind of differential equation and I will just put y is equals to mx, then what is that? Y dash is nothing but x power 4 plus, okay, x power 4 plus 3 x square m square, okay, 3m square, and here it will be x square plus 2m power 4, and it will be sorry, y x power 4. It is not y, it is x power 4 upon, this will be x cube, and it will be m, okay, x. Now what can I do from here? I can take x power 4 common, then it is nothing but 1 plus 3 m square plus 2 m power 4 divided by, it is what, x power 4 m, okay. Now I can just cut it. Here, I can write it in the form of this. It means while putting this value, it is going to separate. It means that one thing is that you can relate, it is a homogeneous kind of differential equation. There is no variable present in this case. Another case, if you have degree of numerator and degree of denominator is equal. See, what is the degree? Degree means what is the power? It is what, 4. It is what, 2 plus 2. It is 4, and it is 4. So the degree of numerator is 4. And the same thing, the degree of denominator is also 4. If the degree are same, then that is homogeneous. So my P is non-homogeneous, wrong. P is non-homogeneous, wrong. From these both, it may be the solution. Second one, if I have this kind of differential equation, and what is the exact differential equation? So the exact differential equation means that whenever you will have this kind of differential equation, m some function of x and y, and it will be d of x. N will be the some function of x and y, and it will be dy is equals to 0. It will be a differential equation called as exact differential equation if my partial derivative of m with respect to y and the partial derivative of n with respect to x will be equal. Okay, now I have this differential equation. This is what, dy by dx is equals to minus of y square upon x square. I will just separate it. So I can write dy is equals to, okay, dy into x square. I will just cross multiply, and it will be minus of y square dx. And I will just write it is nothing but y square dx plus x square dy is equals to 0. Now it is what, m dx plus n dy. What is my m here? And it is 2. Yeah, if I will differentiate partially, it is nothing but dou m by, what is my dou m by dou y is 2 of y, and simply dou n by dou x is nothing but 2 of x. Is these both are equal? No, of course not. These are not equal. It means that it is not exact differential equation. So A is correct, B is the correct answer for this question. Okay, next one. Next one is the differential equation, in which a differential equation is first order linear differential equation. Okay, alpha is a positive constant. If y is equals to 1 at x is equals to 0, then and y is equals to 0.8 and x at x is equals to 1, then the value, what is the value of alpha? See, y dash plus alpha x y is equals to 0. From here, what can I do? I can separate because these both are in multiplication. So it is nothing but dy by dx is equals to minus alpha x. I can write dy upon alpha minus of alpha x, sorry, dy upon y minus of alpha x dx. I can just integrate it. It is nothing but log of y, and it is what, minus of alpha x square by 2, plus I can write constant as log c. Now it is what, log of y minus log of c is equals to minus alpha x square by 2. Then this is y by c. Okay, log of y by c and minus alpha x square by 2. Then my y is nothing but, if I will take like exponential both this side, then I can just write c into e to the power minus alpha square by 2. Now I have, this is the solution. See one thing, from here what can I do? If it is what, y is equals to 1 at x is equals to 0. So if I will put my x, then it will be, yeah, it will be 1. So 1 is equals to c e to the power of 0. Then it is what? My c is equals to 1. If my c is equals to 1, then what can I do next? Y is equals to 0.8 at x is equals to 1. It means if I will now, my solution is nothing but e to the power of minus alpha x square by 2, and it is what? 0.8 is equals to e to the power. If I will put x is equals to 1, then e to the power of minus alpha by 2 will be there. Okay. Now, what can I do here? I will take log both sides. Then it is what? 0.8 is equals to, minus alpha by 2. Then now, what is the value of 0.8? Like from simply, I can just write it is nothing but 2. It is nothing but minus 2 log of 0.8 is equals to alpha. Then alpha will be 0.446. So round up to 3 decimals, the solution will be 0.446 is the correct answer. So you can find easily from this. Okay. So the next question is related to the correct description is, if I have this kind of differential equation in which d3y by dx cube plus x dy by dx power 3 by 2 plus x square y is equals to 0. An ordinary differential equation of order 3 and degree 2. Okay, see, what is the order? Order is nothing but the highest order derivative present in that case. Of course, 3 is the order. So here the order is nothing but 3. So the order is 2, not correct. Order is 3, order is 3. Okay, now degree. Highest order derivative's power. What is the power of highest order derivative? It is nothing but, it is what? If I'm going, okay, see one thing. Whenever you will have, whenever it is talking about the the degree of differential equation, it is necessary that there should not present any kind of radical or any kind of the fractional power in that case. Now order is 3, okay, but if I'm going to write it as y triple dash x y dash power 3 by 2 plus x square y is equals to 0, but here it is what? Radical is present. Okay, after solving the differential equation, what is the degree? So to remove this radical, or to remove this fractional fractional power from this term, I will just multiply, or I will just take a square. So I can like, what can I do here? I will just take, I can write y double dash or y triple dash power square. Okay, plus, okay, what can I do? One thing is here, from here I will just take square of complete of this. If I will take square, then it is what? Y triple dash plus x y dash power 3 by 2 plus x square y power 2 is equals to 0. If I will take power 2, then what will be the solution? It is nothing but x plus y plus z whole square is equals to 0. So the term will be x square plus y square z square, something like this. It means, so what will be the degree of this? So y triple dash or power 2, it means this term will present in that equation. So of course the degree will be 2. So the first option is correct, not second option. Okay, next question. Next question is this, the solution of this differential equation. This is the first order linear differential equation, or you can solve using the variable separation method. If it is a dx by dt, okay, 1 minus q, or I can write it as simple, then it is nothing but dq, 1 minus q is equals to dt. Just 1 minus q is equals to t, then what can I do? Minus of dq is nothing but dt, it means dq is minus of dt. What can I write here? It is nothing but dt upon minus of t. Okay, yeah, dq is minus of dt upon t is nothing but dt. Sorry, oh yeah, t is present also here, then I will just write m here, so it will be dm. Okay, so now it is nothing but log of minus log of m, and it is t plus something called c. Now I will just put my, what is the value of m? That is 1 minus q, and it is nothing but t plus c here. So what can I do from here? It is nothing but log of 1 minus q, and it is nothing but okay, just put the, okay, one thing is that just use the initial case. Initial conditions are given in this case is what? Q is equals to 0 whenever my t is equals to 0, then it is nothing but log of 1 minus 0, and it is 0 plus c. Of course, log 1 will be 0, so c will be 0. So from here, it is log of 1 minus q is equals to t, and it is nothing but 1 minus q is e to the power of minus t. Okay, and from here q is equals to 1 minus e to the power of minus t, so q is equals to 1 minus e to the power of minus t. D will be the correct answer for this question. Next question. Consider the following second order differential equation, and the particular solution of this differential equation is what? What is the particular solution? Whenever you will have this kind of differential equation, y double dash minus 4y dash plus 3y is equals to 2t minus 3t square. Okay, this is the second order differential equation in which you will have, okay, in which you will have the solution is basically complementary function and particular solution. Particular solution is basically the solution of inhomogeneous part, it means, for this. So for this, we'll just write as, like this. It is nothing but y is equals to 2t minus 3t square upon f of d. This is nothing but my f of d. F of d is what? I will just replace y dash with d, y double dash with d square, and y with 1. So what is this? This is nothing but y is equals to 2t minus 3t square. And what is this d? dy, d by d of x, okay? Upon, this is nothing but my d square minus 4d plus of 3. What can I do here? From here, I will just, make it as a binomial kind of distribution, sorry, binomial kind of thing. So I will just take 3 as common. So it is, I can take 3. So it will be 2t minus 3t square, and this will be d square minus 4d upon 3 plus 1. It is what? 1 plus x. Okay, if I will write as here 1 by 3, 1 plus d square minus 4d by 3 power 1, power minus 1. It means if it is power minus 1, then this is 1 minus x plus x square. Okay, minus of x cube. Okay, and multiply with 2t minus 3t square. Okay, now just use it, y is equals to 1 by 3. It is what? If I am going to writing this 1 minus t square minus 4d upon 3, okay, plus d square minus 4d upon 3 whole square, and up to the higher order. So it is 2t minus 3t square. If I'm going to solve this, and I will get, this will be the answer. It means if you will write here, then it is what? 1 by 3. It is 2t minus 3t square. If you are going to multiply with this term, then this is nothing but 1 by 3 d square into 2t minus 3t square minus 4d 2t minus 3t square. What is the meaning of this? It means the twice derivative. So first derivative is what? So t square 2t minus 3t square is what? So if I am going to first differentiate this, then it is what? 2 minus 6 of t. If I am going to again differentiate this, 0 minus 6 will be there. So minus 6 will be there. So the value of this is minus 6. And for this minus 4, it is 2 minus 6t. Okay, and for this again you are going to replace this as a minus b whole square. It will be d power 4, it will be d square, and again you have to use that, and you will get this solution. The calculation will be there, you can find. Next question is, consider the differential equation. Okay, this is x into y dx plus x dy cos of y by x yx dy, yes, dy minus y dx is sine of y by x. For this case, what can I do? I can write it as x dy of dx plus x dy upon y uh, x dy minus y dx is nothing but sine of y by x upon cos of y by x. If I will take this y by x is v, okay, and I am going to solve this. Okay, this is, and after that you can just take it as a, the spatial kind of thing. The solution will be, from here, the if it is a basically non-linear kind of thing. So this c will be the solution. So x of y cos of y by x is equals to c. It means by taking, okay, you can take this one also, or you can use the the thing like this, like y y dx. Okay, yeah, x dy plus y dx, and again it is x dy minus y dx. In this case, what is this? If I'm going to taking this as like whenever you will have present this kind of thing, and you can just separate, you can take y is equals to vx. If you are taking this, then you can easily separate. Okay, this is the 2015 question, and the correct answer is this. The calculation is there. This is a substitution. You can substitute and solve it. Next question. Consider the following second order linear differential equation. Okay, with the boundary condition is this. So what is this? This is y double dash minus 12x square plus, okay, minus 12x square plus 24x minus 20. So first of all, what is the complementary function? You're going to taking this m square is equals to 0. If m square is equals to 0, it means my m is equals to 0 comma 0. These both are what? These both are repeated root and real root. Then y of c is nothing but c1 plus c2x e to the power of 0x is nothing but c1 plus c2x, complementary function. The particular integral in this case will be the same. Y of p is nothing but the right hand side. This is nothing but q of x divided by f of d. Here it is d square. Then y of p is nothing but minus 12x square plus 24x minus 20 divided by d square. This is nothing but the, what is this? 1 by d is nothing but the integration, and 1 by d square is nothing but double integration. So yp is nothing but 1 upon d, and we are going to integrate this thing with respect to x. So it is what? 1 by d. The integration is what? Minus 12 x cube by 3 plus 24 x square by 2 plus 20x. Again, you are going to integrate this thing, then this will be particular integral minus 12 by 3, or it is nothing but 4. Yeah, okay, we can just easily write it as 4. So y of p minus 4 x power 4 upon 4 plus 24, and it will be 12 x cube by 3 and plus 20x square by 2. Now it is nothing but minus of x power 4 plus, okay, plus 4x cube, and it will be 10 of x square. So the complete solution y is equals to c1 plus c2x minus x power 4 plus 4x cube plus 10x square. Now here we have two arbitrary constant and two conditions are given here. What is that? Y of y0 is 5 and y2 is 21. Just put it here, 5 and x0. What is this? These all term will be 0 here. So it is what? C1 is equals to 5. And second thing is that it is 21 if it is C2 into what? It is 2 minus of 2 power 4 plus 4 2 power cube plus 10, okay, 2 power 2. While calculating this, you will get one C2. If after that you are putting this C2 here and y is equals to C2 into what? At x is equals to 1. So this will be 1 minus 1 power 4 plus 4, 1 power 3 plus 10 into 1 power 2. Whatever the value of C, and after solving this, you are getting the answer is y is equals to 18. This is the solution for this question. Next. Next question is the integrating factor for the differential equation. What is the integrating factor? Integrating factor for the linear differential equation, whenever you will have this kind of thing, this is what? Okay, whenever you will have this kind of dy by dx, okay, plus some p of x, y is equals to q of x. This is the complete function of x. Of course, it is the complete function of what? T. Now after that it is what p of x, the integrating factor is integration of integration of p of x. So what is this? It is k2. So the integration of k2, it is constant. So the integration of k2 with respect to t e to the power of k2 into t. So the correct answer is D. Next. So the next question is related to again the linear differential equation with the boundary with the condition. Okay. So it is a solution, the differential equation, solution of ordinary differential equation. It is a variable separation method we can apply. This is nothing but dy by 2y is nothing but minus of, okay, we can write it as 2x plus some c if I'm going to integrate this. Then this will be log of y minus of 2x plus c. Okay. Next thing is that what can I do? I can just write it as like this log of c. Then this is nothing but log of y by c is equals to minus 2x. Then y is equals to c to the power of minus 2x. It is saying that at x is equals to 1 it is 5. Then it is 5 is equals to c to the power of minus 2. Then it is 5 e to the power of plus 2 is equals to c. This is the value of c. Then y is equals to 5 e to the power of 2 e to the power of minus 2x. Then y is equals to 5 e to the power of 2 minus 2x. Okay, for the boundary condition here. Okay, one thing is that this can't be correct. This can't be correct. From here and here it may be correct. Okay, what is e? It is 2.75 and its square is something 4 point something. And if I'm going to multiply with this, or not 4 point, it will be 5 point something. And if I'm going to multiply this with, of course it not be 10, this will be the correct answer. Not calculating exactly, you can take it the answer, or this is the correct answer for this. Next, this is the question here. It is a linear differential equation again, and it is what? Dy by dx plus y upon x is equals to x. Now what is the integrating factor for this? E to the power of 1 by x of dx is nothing but e to the power of log of x. Okay, and here it is nothing but x. Yes, so the solution is y into integrating factor, right hand side into integrating factor of dx plus c. So y into x, so this will be x square, x into x square dx plus c. So y into x is equals to x cube by 3 plus c. And the given condition is that y at 1 is equals to 1. So x is 1, it is 1, so it is 1 by 3 plus c. 1 minus 1 by 3 is equals to c. It means my c is nothing but 2 by 3. So the solution for this is nothing but y into x cube by 3 plus 2 by 3. Then okay, from here we can find that it is nothing but x square by 3 and it is 2 upon 3x. Okay, 2 upon 3x plus x cube by 3, x square by 3. So D is the correct answer for this question. Next one, what is the order and degree of this differential equation? For this, first of all, one thing is that whenever you will have this kind of thing, first remove this radical part. How can we remove this radical part? Just like this, y triple dash is equals to minus of 4 root of y dash cube plus y square. Okay, now take the square both sides. It is nothing but y triple dash square is equals to what? Minus or plus 16, and it is nothing but y dash cube plus y square. Okay, now what is the order? Highest order is 3 and the degree is 2. It is what saying the order is 3, degree is 2. So the first is the correct answer. One thing is that remove any kind of fractional power from the differential equation. Okay, next question. Next question is again second order linear differential equation, in which it is what? It is y double dash plus y dash minus 6y is equals to 0. Okay, so auxiliary equation is m square plus m minus 6 is equals to 0. Then it is what? quadratic equation. What are the root for this equation? After multiplying, it is minus of 6. Then it is nothing but m plus 3 and m minus 2. Okay, m minus, yeah, is equals to 0. It means m is equals to minus 3 and m is equals to 2. So the correct answer is minus 3 and 2. C will be the correct answer. Next question. The solution of this differential equation is representing the family of what? See, whenever you will have this kind of differential equation, you can easily separate this variable. Okay, now you can take, it is this variable separate form, 3 of y dy is equals to minus 2x dx. After integrating, it is nothing but 3y square by 2 is equals to, and it is what? Minus 2x square by 2 plus c. It is y square upon 2 by 3, and it is plus x square upon 1 is equals to some constants. It is nothing but the equation of ellipse. If it is minus, if there is minus, and it is hyperbola, but it is what? It is representing a ellipse. So the first option is correct here. Next, the degree of the differential equation. What is the highest order? Highest order is 2. And what is the power of this highest order derivative? Is 1. So the B is the correct answer for this question. So it is just a first order linear differential. It is for confusion, sorry. And it is nothing but x square y dash plus 2xy minus x plus 1 is equals to 0. So from here I can write it as y dash plus 2 upon x y, and it is nothing but 1 by x square plus or minus 1 by x square plus 1. I have just divided x anywhere x square in all the terms. Upon x will be there, of course. Yes. Next, what is the integrating factor? After finding the integrating factor, we will have e to the power of 2 by x. Integration of this is nothing but e to the power of 2 log of x. Then it is nothing but e to the power of log, and it is x square. So the integrating factor is x square. Solution is y into integrating factor is equals to the right hand side. That is 1 upon x square minus x upon x square, or that is minus 1 upon x square, and it is plus 1 upon x, and its integration and multiply with x square dx plus c. So y into x square, if I will multiply here, then it is minus 1 dx, plus if I will multiply here, then it is x dx plus c. Then y x square is equals to minus x plus x square by 2 plus c will be there. So y is equals to minus of x upon x square plus 1 by 2 plus c upon x square c. If it is nothing but 1 upon x, so here it is 1 upon minus 1 upon x plus 1 by 2, 1 by 2 plus c upon x square. One thing is that if it is minus 1 by 2, it's not correct. It is 1 by 2, 1 by 2, 1 by 2. Okay. It is what? Minus 1 by 2. Then it is also not correct. From here and here it is. So we have to calculate c. So to calculating c, we have what? Y is equals to 0 at x is equals to 1. If I will put x is equals to 1, then it is c and it is 0. Of course, oh, sorry. It is minus 1 plus 1 by 2 is equals to c. Then my c is nothing but minus 1 by 2 is equals to c. So here it is minus, so b is the correct answer, a is not correct. So this is the trick how you can discard the options. Okay, next question. Next question is related to, okay, yeah, it is nothing but variable separation. Then dy upon 1 plus y square is equals to d of x. I'm going to integrate, then this will be of course tan inverse of y. It is what? X plus c. Then what is y? It is nothing but tan x plus c. So c is the correct answer. Next question. It is a differential equation. Whenever you will have this kind of differential equation, it is what? F of x and y, d of y, and plus g of x and y, it is dx is equals to 0. Okay, I have just multiplied dx both the sides. So this is what m and x. What is the condition? The coefficient of y. Okay, the partial derivative of coefficient of y with respect to x should be equals to the partial derivative of coefficient of z with respect to y. So this is the condition where the differential equation will be the exact differential equation. So f with respect to y is not correct, not correct, not correct. This is the correct answer. So B is the correct answer for this differential equation. Okay, next one is that the differential equation is homogeneous, non-linear, second order linear or non-homogeneous with constant coefficient. One thing is that what is saying that constant coefficient, the coefficient of y test is constant. No, so the D is not correct answer. What is the homogeneous? Homogeneous case in this sense, whenever you will have second order or any higher order differential equation in which the right hand side, this is what the right hand side. Okay, if my q of x is 0 here, then it will be homogeneous, but it is not 0, and it is not homogeneous. Another thing is that what is non-linear case? If it is what non-linear case means that, wait, it is not 11, it is dash, it's not 11 and 1. Okay, non-linear case. Non-linear cases means that any higher power of y, like y square, y cube is present in the differential equation. No. Another thing, if my dependent variable, it means if it is dy by dx, then y is function of x. It is dependent variable. If this dependent variable is multiplied with this, its derivative, is it present? No. Okay, second thing is not present. Third thing, any kind of non-linear function like sine of y, e to the power of y, cos of y, it means non-linear function of dependent variable is present in that equation. Of course not. So it is a linear differential equation. So this is not correct. This is the correct option because this is the second order. It is y double dash. Of course, it is a second order differential equation. Next question is that again, what is the necessary and sufficient condition for a differential equation to be exact? If it is a coefficient of x and if it is a coefficient of y, then the partial derivative of m with respect to y and the partial derivative of n with respect to x. So what is the C is the correct answer for this question. So thank you so much for watching my video. Keep watching MS Maths, and for this kind of previous year question, you can follow my YouTube channel, subscribe the YouTube channel, like the video, share the video, subscribe, and click on the bell icon. Thank you. Thank you so much.